Is it on? There it is. Okay, I want to do this problem together. Sound good? Cool. Okay, so part A, I'm going to show that if z is cosine theta I sine theta, which is just cis theta, I'm going to show that z to the n plus 1 over z to the n is 2 cosine n theta. So not as bad as it might look, but maybe intimidating right away. Okay, so if z equals cis theta, right, which is cosine theta I sine theta, then z to the n would be cis n theta. Remember, we take that exponent and we multiply it by the angle, and we take the modulus to that power. So, of course, the modulus there was 1, so 1 to the n is said thing. Okay, this is scary, right? This looks scary. But what's that equivalent to? Z to what power? Negative 1, or the negative nth power. Therefore, z to the negative n is equal to cosine negative, excuse me, not cosine, cis negative n theta. Okay, now I want to show that if I add these two things together, that they're going to equal 2 cosine n theta. And there's one little scary thing in here. So if I have cis n theta plus cis negative n theta, let's expand both of these. So this would be cosine theta plus n theta plus I sine n theta. And this one over here would be cosine negative n theta plus I sine negative n theta. Okay, so do you guys remember even odd functions? Is cosine even or odd? It's even, because if you reflect it over the y-axis, then it looks exactly the same. So do you remember this property? Cosine of negative theta is equal to what? Cosine of theta. So in this case here, if I have cosine negative n theta, that's actually equal to positive due to the fact that it's an even function. Sine is not an even function, therefore sine of negative theta is equal to negative sine of theta because it's an odd function. Right? So what happens here with the negative going along with the sine is we get that comes out as a negative out in front here. Okay, so the angle becomes positive, but the value of that becomes negative. And then when I add these two together, I have cosine n theta plus cosine n theta, which is 2 cosine n theta. And then I have positive I sine n theta and negative I sine n theta, which cancel. Proved it. Sweet. Done. Okay, so the only exchange of what's going on there, the only new thing that might feel like that's foreign is the fact that there's even odd, but you know that it's just kind of embedded, right? So maybe a little scary. Okay, so the second piece of this problem is the part that's going to maybe look even more intimidating, but what if I took z plus 1 over z to the 4th power? I want to show if I expand that it equals that ugly thing. Okay, so z plus 1 over z to the 4th power. Okay, I don't really like that format. So what I'm going to do is instead of 1 over z, I'm going to make this z to the negative first. Z to the negative first. Now let's expand using Pascal's triangle. Row 4, what numbers do we have? 1, 4, 6, 4, 1. Okay, so I have 1, 4, 6, 4, 1. Now let's talk about powers and how we're going to decrease and increase. This would be z to the 4th, then z to the 3rd, then z to the 2nd, z to the 1st, and z to the 0. Okay, same thing for this. That'll be z to the negative first to the 0, then z to the negative first to the 1, and z to the negative first to the 2, and z to the negative first to the 3, and then z to the negative first to the 4th. Okay, I'm just going to add those together. Let's combine and clean this thing up a little bit. So if I combine and clean this up, what does this first term become? Z to the 4th. I'm just going to skip for a little bit. What is this one going to become? Z to the negative 4th, or 1 over z to the 4th. I'm going to write it as z to the negative 4th. Okay, and I'm going to group those, and you'll see in a moment why. Okay, what would this one become? 4z to the 2nd. So I have a z to the 2nd. You'll see what I'm going to do in a moment with that. Over here, that would be 4z to the negative 2nd. So if both of those have a 4 on them, I'm going to factor that 4 out, and you'll see why in a moment. This term right here will just be a constant. So z to the 2nd, z to the negative 2nd will cancel, and I'll get 6. Now how do I get from where I am to where I want to be? Well, what did we say that this equaled above? 2 cosine n theta. What is n? 1, right? So it'd be 2 cosine theta. And I'm taking that to the 4th power. Okay. Okay, so 2 to the 4th is 16. And cosine to the 4th would be cosine to the 4th. Okay, over here, if z to the n plus z to the negative n is equal to 2 cosine n theta, then what is n in this case? 4. So how could I write that? This would be 2 cosine what? Z to the n plus z to the negative n is 2 cosine n theta. So z to the 4th plus z to the negative 4th would be 2 cosine 4 theta. Okay. On to the next one. Z to the 2nd plus z to the negative 2nd would be 2 cosine 2 theta. And then the last piece is 6. Okay. All right, so let's simplify and show that whatever it is that was written above is true. I want to solve for cosine to the 4th. And what do I want it to be? I want it to be 1/8 of that thing. Let's see if we can show that's true. Okay. Well, if I want to just get cosine to the 4th alone, I'm going to divide by 16, which means I'd divide this side by 16 as well, which would mean 1/16 of 2 cosine 4 theta plus, I'm going to distribute that, plus 8 cosine 2 theta plus 6. Okay, but I want it to look like this. I want a 1/8 on the outside. Let's see if we can do some work. Let's make that a 1/8. So that means that a 2 has to cancel. So 2 cancels there. The 8 will become a 4, and the 6 will become a 3. So we've got cosine to the 4th theta equal to 1/8 cosine. Is this what we were supposed to get? Okay, so this is one of those problems where you have the end in mind. You know what you're supposed to get in the end. And you just have to use the properties that you're aware of to do so. I don't know if... So we turned... let's see here. This right here poor color choice, but you can kind of see that. That right there is z to the n plus z to the negative n. So in that step, we showed that z to the n plus z to the negative n equals 2 cosine of n theta. So if I were to throw a 4 in there, well, you could then say that's 2 cosine 4 theta. Right? If I were to throw an 8 in there, you could say that's 2 cosine 8 theta. Whatever number I plug in here for n, as long as it follows that same format, you could throw that in there. Nothing, the 2 won't change in the front, just that value. And that's de Moivre's theorem in practice. Of theta, correct. In this form only. So z to that power plus z to that negative power will equal 2 cosine of n times whatever your angle is.
Will the power and the power always be the same?
Yeah, they have to be. In order for that to work, they have to be. Yeah, powers have to be the same there. But let's talk about it just for a moment. If z plus 1 is a factor, what else has to be a factor? Or z plus 2i, then z minus 2i. So I know that these two are true, right? They come in conjugates. So I know that these two have to be factors because they come in pairs, and the pairs are conjugates of each other. Okay, so that means I only have one more factor, right, to give me this polynomial right here, 2z cubed, minus 3z squared plus 8z minus 12. Okay, so you can already anticipate what would my variable portion of this have to be? Not just z, 2z. So I'm going to have a 2z there, and I gotta figure out something else to figure out what I need there for in order to get a negative 12. You know what I have to have here to get a negative 12 out as a constant. So if I were to FOIL this, what's the advantages of foiling? Yeah, it's just Florida, right? No FOIL, you're just full. So z times z is z squared. Negative 2i times 2i is negative 4i squared. And that will be negative 4 times negative 1, which is 4, right? So I have z squared plus 4. I have no linear term in that quadratic there. Okay, so I have z squared plus 4. So I don't have to do all the work that someone's going to do. Someone will do it. I mean, it's just going to happen. 2z minus 3, right? Because you just took, and you said, okay, 4 times what will give me negative 12. And so it has to be minus 3. All right, so now you have your three factors, z plus 2i, z minus 2i, and 2z minus 3. You can find the solutions or the zeros. Those are the factors. Just remember your zeros would be minus 2i, and what would that be, 3/2? Those would be your zeros. All right, cool.